Lesson is Unit 11, Lesson 11, Reciprocal Trig Functions. And before we start this, which is on page 388, before we start this, if you could just grab a sheet of paper, and I want to write down what you need to know so far, okay? So first off, we're all familiar with SOHCAHTOA, our three trig functions. And we're going to add to these three another 3 today. So SOHCAHTOA, sine is equal to opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. We also want to know about our unit circle. So just sketch a quick x and y axis and mark the 4 points that we would use to guide us in drawing the unit circle, and label those points with their coordinates. So this here would be 1, 0, 0, 1 at 90 degrees, negative 1, 0 at 180 degrees, and 0, negative 1 at 270. So let's also put some degree measures here. And one full rotation is 360 degrees. When we have a point on the unit circle, so if I try to draw the actual circle here, if we have a point xy on the unit circle, then the x-coordinate is equal to the cosine of the angle, and the y-coordinate is equal to the sine of the angle. These are things you have to know, right? You don't want to be referring to your paper plate each time to look it up. All right, you've got to be able to take a blank sheet of paper like I'm doing here, and you're doing with me, and write all this information down. Remember our quadrants. 1, 2, 3, and 4. And our all students take chemistry. So in quadrant 1, all our trig functions, all 3 trig functions are positive. In quadrant 2, so all students, S is for sine, is positive in quadrant 2. All students take, tangent is positive in quadrant 3, chemistry. And the C is for cosine, is positive in quadrant 4. The Pythagorean identity. Pythagorean identity is cosine squared theta plus sine squared theta equals 1. So for any angle measure, the cosine of that angle squared plus the sine of that angle squared is going to equal 1. That is true for any angle measure. So this can be used when if we're given sine and we want to find the cosine value, right? Or if we're given cosine and want to find the sine value, or if we need to find cosine or sine and then use the two of them together to find tangent. What do we do when their point is not on the unit circle? If the point is not on the unit circle, we would actually, you could plot the point, draw a right triangle, and then use Pythagorean theorem, which is a squared plus b squared equals c squared, to find the missing side length, and then use our SOHCAHTOA. Or you can remember or memorize that when the point is not on the unit circle, that the cosine of your angle is going to equal x over r. The sine of your angle is going to equal y over r being the radius of your circle that is not the unit circle. And then tangent is y over x. And one last thing. Which escapes my mind right now. Well, hopefully I can edit this video. Oh, here we go. You also have to know that tangent theta is equal to sine theta over cosine theta. All right, so there's a lot of information here, and you need to know this. All right. So we will practice some of this today with today's lessons because we're expanding on sine, cosine, and tangent today, looking at our 3 reciprocal trig functions. So going to page 388, and the plan is to do page 388 and 389 together. So you're watching the video and filling in the notes along with watching the video. And please, pause the video if you need to. If you need to pull out your calculator and do something, or if you want to try the next problem on your own. All right, definitely pause the video and try the problem on your own before just copying it down from what I'm presenting to you. I'm going to ask you to try page 391, numbers 5 through 9, and then your homework is going to be the Delta Math Unit 11, Lesson 11, Reciprocal Trig Functions assignment. All right, so here we go. So our 3 main trig functions are sine, cosine, and tangent. Each of these can be defined in terms of either ratios of the sides of a right triangle, SOHCAHTOA, or the unit circle. So sine, cosine, and tangent each has a reciprocal trig function. Their definitions are shown below. Right, so we have secant, which is abbreviated using the first 3 letters of secant, is abbreviated SEC. Secant of theta is equal to 1 over cosine theta. So please write that down. You have to memorize this. Secant is equal to 1 over cosine. I remember secant is equivalent to 1 over cosine. I associate it with cosine because if I look at secant backwards, we have CES, which is similar to COS for cosine. So secant is equal to 1 over cosine. I also like to use the words secant is equivalent to the reciprocal of cosine. Then we have cosecant. Cosecant is abbreviated with the letters CSC. So CSC, that means cosecant. You would read this cosecant theta is equal to 1 over sine theta. So cosecant is equal to the reciprocal of sine. And I remember, well, the trick I use is the S here in the middle, right? That single S is for sine. And cotangent is abbreviated by the first 3 letters, COT. So COT, we don't say cot, rather this is cotangent theta is equal to 1 over sine theta. So cotangent is equal to 1 over tangent. Now remember, we know that tangent is equal to sine over cosine, so cotangent would be the reciprocal of that. So cotangent theta is equal to cosine over sine. So 3 more things you need to memorize. So 3 things to add to our sheet in the beginning, or actually to add to our paper plate, is our reciprocal trig functions. So secant theta is equal to the reciprocal of cosine. I'm just going to say recip cos. Cotangent theta is equal to the reciprocal of tangent, and vice versa. Tangent would be equivalent to the reciprocal of cotangent. Cotangent is reciproc tan, and cosecant, that's the reciproc of sine. And we can also put this on our paper plate. Right. Cosecant is a recip of sine. Secant is equal to the reciprocal of cosine, and cotangent recip of tangent. And remember that tangent is equal to sine over cosine, so cotangent would be equal to cosine over sine. Considering our work with sine, cosine, evaluate the following, express answers in exact simplest form. Okay, so I need you to change some of these angles here. We're going to change secant of 60 degrees. We're going to just make that 0 degrees. And cotangent of 150, the 150 we're going to cross off and make 180 degrees. And cosecant of 3 pi over 4, we're going to make this 3 pi over 2. Okay, so these are all quadrantal angles. So I'm going to use a unit circle to help me in answering these questions, all right? So let's just draw a diagram of our 4 points. Label their coordinates. And let's put some angle measures around. So if we're asked for the secant of 0 degrees, well, secant, remember this backwards, right? CES is close to COS. So secant of 0 degrees is going to equal the reciprocal of cosine. So that'd be 1 over cosine 0 degrees. All right, so go to our 0 degree angle. The cosine value is the x-coordinate, which is 1. So this would equal 1 over 1, which is 1. The cotangent of 180 degrees. Well, cotangent is the reciprocal of tan. And if I know that tangent is sine over cosine, then cotangent is cosine over sine. And when we're on the unit circle, cosine is the x-coordinate, sine is the y-coordinate. So that would be negative 1 over 0. When you have a 0 in the denominator, what is it? Undefined. C, we're asked for the cosecant of 3 pi over 2. Well, 3 pi over 2, this is radian measured. So to convert to degrees, we need degrees in our numerator, so we need 180 degrees in our numerator and pi in our denominator. So we multiply by 180 degrees over pi. Our pi's divide out. 2 goes into 180 90 times, so 3 times 90 is 270, or you could use the calculator if you want. So this is equivalent to the cosecant of 270 degrees. Cosecant is the reciprocal of sine, so it would equal 1 over sine 270. (270-degree angle), the y-coordinate is -1. So this is equal to 1 over -1, which equals -1. For exercise 2, you'll need a calculator. Which of the following is closest to the value of secant 52 degrees? Well, first off, secant we know is equivalent to the reciprocal of cosine. So this would equal 1 over cosine of 52 degrees. Our calculator needs to be in degree mode. So if I press mode, the fourth one down from the top, what's darkened is the default mode. Right now I'm in radian, so arrow over to degree, press enter, and then second mode takes us back to our home screen. And now we will key in the fraction 1 over, press cosine. Let's see if I move this up some more. There we go. 1 over cosine 52. So 1.624269. Option 2. Because secant, secant, cotangent. Well, secant, the abbreviation is SEC. Cosecant, the abbreviation is CSC. And cotangent, the abbreviation is COT. Have variable denominators. There are angles which make these denominators equal 0, making the function undefined, which we saw in exercise number 1b above. Which of the following values of x is not in the domain of cosecant x and y? Okay, well, cosecant, write that s there, that's equivalent to the reciprocal of sine. So that's 1 over sine x. We know it has to be a quadrantal angle, so the question is it 180 degrees or is it 90 degrees? So for 90 degrees, our point, the coordinates are 0, 1, and 180, -1, 0. Sine here is 1, and the sine here is 0, the y-coordinate. And that's for 180 degrees. So when is sine of x equal to 0? When x, yeah, I'm not liking the x here. This is for an angle x. We actually want the y-coordinate. Don't be confused. All right, x is a variable. It's not the x-coordinate. Signs in our quadrants, right? Because each of these functions depends on sine, cosine, or tangent, we determine the sign, positive or negative, based on the quadrant of the input angle using our all students take chemistry. So draw just an x and y axis. All students take chemistry. Quadrant 1, 2, 3, and 4. Determine the sign of the following trig functions in the quadrant given. This is cotangent beta for beta in quadrant 2. Well, cotangent's the reciprocal of tangent. So in quadrant 2, tangent is negative. So cotangent of beta would be negative. Secant beta, this is the recip of cosine. So I'm thinking, oh, 1 over cosine beta. In quadrant 4, well, in quadrant 4, cosine is positive. Cosecant beta, this is the recip of sine, right by the S there. So 1 over sine beta in quadrant 3. Well, sine in quadrant 3 is negative. If cotangent, exercise number 5, if cotangent beta is less than 0, meaning if it's negative, and I'm thinking, oh, cotangent, that's the reciprocal of tangent. So if tangent is negative and secant is the reciprocal of backwards CES, close to COS, is the reciprocal of cosine. Cosine is greater than 0, cosine's positive, then what quadrant are we in? Well, cosine's positive in quadrants 1 and 4, and of those two, in which one is tangent negative? Quadrant 4. Right? So our angle measure has to be here in quadrant 4, which would be option 2, the 310-degree angle. We should be able to produce all 6 of the trig ratios if we are given 2 sides of a right triangle. So in exercise number 6, we have a right triangle shown below with sides of lengths A and B. So lowercase a is opposite angle A. Lowercase b is opposite angle B. Find the length of the hypotenuse in terms of A and B, labeled on the diagram. All right, so our hypotenuse, which would, in this case, lowercase c, is going to equal, we use our Pythagorean theorem. So we know that a squared plus b squared, leg squared plus leg squared, is going to equal the hypotenuse squared. So we just square root each side. So c is equal to the square root of a squared plus b squared. State the value of each of the following trig ratios in terms of constants a and b. Okay. So this is sine, so, cosine, ca, tangent, toa. So the sine of angle A. So in relation to angle A, opposite is lowercase a, and hypotenuse is square root of a squared plus b squared. So this would be equal to a over square root of a squared plus b squared. Cosecant is the reciprocal. So that means it would equal hypotenuse over opposite. So the hypotenuse, the square root of a squared plus b squared over lowercase a, right? Cosecant is simply the reciprocal of sine. So you just want to take the reciprocal of sine. Cosine theta is adjacent over hypotenuse. So in relation to angle A here, the adjacent leg is B over hypotenuse. Cosecant is the reciprocal of that. It's going to be hypotenuse over adjacent. Yeah, this A is adjacent. And again, I know, you know, you can pause the video and just go through these on your own if you like. Tangent is opposite over adjacent, A over B. And cotangent is the reciprocal, B over A. Exercise 7. If alpha is an angle whose terminal ray lies in the quadrant 4, and cosine alpha is equal to 1/3, then determine the exact value of cosecant alpha. Show your work. Okay, so we're in quadrant 4, and cosine of alpha is equals 1/3. Cosecant alpha, that's the reciprocal of sine. So cosecant of alpha is going to equal reciprocal of sine. I'm going to draw a triangle in quadrant 4. Label alpha. Cosine is adjacent over hypotenuse. So the adjacent side is 1, and the hypotenuse is 3. We need to find the length of the side opposite. We use Pythagorean theorem. 1 squared plus b squared equals 3 squared. 1 plus b squared equals 9. Subtract 1, b squared equals 8. Square root both sides, b equals plus or minus the square root of 8. So this would be the square root of 8. We are in quadrant 4, where sine is negative. Oh, I meant to write, well, sine, I'll say sine of sine. It's negative in quadrant 4. Reciprocal of sine, if sine is opposite over hypotenuse, this is hypotenuse over opposite. So our answer for cosecant theta is 3 over square root of 8, and add the negative sign. Now, if you run into a question on delta math where you end up with a radical in your denominator, they may ask you to rationalize it. In which case, this is acceptable for me for an answer, but if you were to leave it that way in delta math, they're going to mark you wrong, all right? To rationalize, well, first let's just simplify this. This is negative 3 over 2 square root of 2, all right? Now, we don't want to leave a radical in the denominator here, so if I multiply by 1 in the form of square root of 2 over square root of 2, that'll get rid of this square root of 2 in the denominator. So we have negative 3 square root of 2 over square root of 2 times square root of 2 is square root of 4. Its square root is 2. Excuse me. 2 times 2 is 4. All right? So this would be an equivalent answer with a rational denominator. Now pause the video, please, and try page 391. Right, we're skipping page 390. That's out. Page 390 is out. And go on to page 391. Pause the video, try these on your own. All All right, coming back. For which of the following values of alpha is cotangent alpha undefined? This is the reciprocal of tangent, or we also want to think that cotangent alpha is going to be the reciprocal of tangent, and I'm thinking, oh, tangent's equivalent to sine over cosine. So cotangent alpha would be cosine alpha over tan alpha. No, sine alpha. So we know it has to be a quadrantal angle. Is it either 90 or the 180? Well, 90 degrees. Coordinates are 0, 1. Cosine is the x-coordinate, and the y-coordinate is sine. So this would be 0 over 1, which is equal to 0. So it's not 90, it must be the 180 degrees. 180 degrees, thinking of the point -1, 0. This is cosine, this is sine, so that's the one. -1 over 0 is undefined. For which angle beta below will secant beta not exist? So in other words, secant, that's the reciprocal of cosine. So when cosine of beta is 0. 180 degrees, that's -1, 0. The cosine is -1. That's not going to give us an undefined value. This is the one. Went over 0. Is undefined. 7, determine whether each function in the table below is positive or negative for angles in the respective quadrants. Use the table in Part A to help create the table in Part B. Remember, all students take chemistry. Quadrant 1, cosine and sine are positive. Quadrant 2, sine's positive, cosine's negative. 3, cosine, only tangent is positive, so both sine and cosine are negative. In quadrant 4, cosine's positive, sine is negative. Tangent in quadrant 1, positive. Cotangent's going to be positive, so is secant and cosecant. In quadrant 2, I'm thinking only sine is positive, and the reciprocal of sine is cosecant. So I'm just going to write here cosecant, this is the reciprocal of sine. Secant's reciprocal of cosine, and cotangent is reciprocal of tangent. So in quadrant 2, sine and cosecant are going to be positive. All others are negative. In quadrant 3, tangent is positive, and its reciprocal trig function, cotangent, would be positive. The others negative. And in quadrant 4, cosine and its reciprocal, which is secant, is positive. All others are negative. Number 8, for angle beta, it is known that cosecant beta is greater than 0. Okay, so I'm thinking 1 over sine is positive. Secant, that's the reciprocal of cosine, 1 over cosine, is less than 0, is negative. What quadrant are we in? Sine's positive in quadrant 1 and 2. And it's in quadrant 2 that cosine is negative, so we're definitely in quadrant 2. And number 9, the angle theta, when drawn in standard position, has its terminal ray in the second quadrant. If it is known that sine theta equals 5/13, okay, so we're in quadrant 2, and the sine of our angle is 5/13, then determine the value of all the remaining trig functions. All right, so I'm going to draw a diagram. We're in quadrant 2. So I'll draw a right triangle in quadrant 2, label my angle theta. Remember, our right triangles, they always go to the x-axis. Never draw a triangle where the y-axis is a side of the triangle. It's always the x-axis that needs to be a leg of the triangle. So opposite, hypotenuse, 5, 13. This is the triple, 5, 12, 13. If you didn't know the triple, then you're just doing 5 squared plus b squared equals 13 squared. That's 25. 169 subtracted from 169 is 144. So b is 12. Cosine is adjacent over hypotenuse, so in relation to our angle theta, 5 is opposite, the 12 is our adjacent side, and 13 is our hypotenuse. So we have 12 over 13, but we are in quadrant 2 where cosine is negative, so negative 12/13. B, tangent theta's opposite over adjacent. 5/12. Tangent is negative in quadrant 2. The answer is a negative 5/12. Secant is the reciprocal of cos. So if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. So hypotenuse is 13, and adjacent is 12, and it's negative. And sometimes, just so I don't forget about the negatives, this 12 here is at the negative portion of the x-axis, so I might kind of just put the negative there so that I don't forget it when I'm answering the trig value questions. Cosecant is the reciprocal of sine, and sine was given to us as 5/13, so its reciprocal is 13/5. And we're in quadrant 2 where sine and cosecant are positive. And cotangent is simply the reciprocal of tangent, negative 12/5. Okay, thank you for listening and taking the notes. And your homework, again, is the Delta Math assignment.